messages. Oh, that's really fucking nice. It so I had a button now that explained the current project I'm working on that I could just press to put in chat a message of what I was doing, right? So I can kind of spam that, what is pretty cool. Right. So next up, I just put a blanket. Right. So I wanted to work on the Raytracer. Well, I mean, obviously, I see from the title, right? So let me show you what I've currently done. So one of the things I was thinking is the Raytracer currently is, or the UI is currently not running on a separate thread, right? So it's just part of the main update. So I kind of wanted to run the UI in a separate loop. So the UI would have a fixed update, right? That way it would run at 60 FPS, and the only issue I could see with this is we're changing settings, right? So they would be applied mid-rendering, what could be problematic, but we can see how problematic that will be once we actually start rendering, right? Or we actually start doing things. Because I think it might be fine, because it would mess up the current frame for sure. But the next new frame would be fine. In the meantime, I'm gonna take off my shirt while I'm thinking on how I want to approach this, because it's really, really hot in my room. That's better. Right. So, right, coming back to the thing I was talking about, right? Yeah, the separate thread. So I'm thinking what would be a good approach for this, because we can just run it in a separate thread, but in like a busy loop, right? And just have it update every while, or every time the while ticks over. But that would be keeping the CPU quite busy. What would take away from performance from the ray tracers. So it would be nice to have the sleep. Oh, I think I could just have the thread yield for a certain time. Yeah, so I think what we could do in the ray tracer, right? We could add a. No, sorry, it would be in the application. We could make a UI thread. Subtech, thank you for joining in. So let me show you real quick what I've been doing. So I've been making a ray tracer, and I think one of the last streams we got refractions in, so we can look through objects. Although currently these don't have that at the moment. And I've been working on adding some tools so I can visualize things like spatial partitioning, what can help a bit with debugging. Although I think my visualization has a problem. It doesn't quite look correct, but that's fine. And some other cool debug things like being able to visualize how expensive pixels are to render. So I can see that air is green, what is very cheap to calculate, while overlapping objects are very expensive to calculate, relatively speaking, right? Although this scene is relatively cheap. And you can tweak this sensitivity because it's using time to basically calculate the pixel cost, right? So the more FPS you have, the more you need to tweak it. Yeah, thank you. Thank you. But yeah, we can do different things as well. So we can make the potatoes, for example, see-through as well. So what we can do is the following, right? And then the potatoes will be see-through. So we can see through the potatoes. But they kind of... It doesn't look quite right. As it kind of... How would I say it? Yeah, it takes a lot of the background color, right? And since everything is green, it basically takes the green background. So I think something like a sky sphere would actually make this much better. So I am debating now actually, because I wanted to do a sky sphere, if I should do a sky sphere today or work on the UI. Because the current problem with the UI is, right, it's updated once a frame. So now we're running at 12ish FPS, right? So the UI is responsible enough, right? We can move it with some difficulty, but we can see if we pop out this window, right? Like, it doesn't always cooperate that nicely. You can see it's definitely chugging, right? Oh, yeah, it doesn't show on stream. Okay, that's great. But I can redock it, right? But settings like apply in a reasonably close thing. So I was thinking of making the UI run on separate threads so the UI would be smooth. But that had quite some problems as well, right? Because obviously you can only really apply the settings in the UI the next rendering frame. Because the depth view or the normal view, right, switches at the entire rendering for a different method. So if you do that mid rendering, like let's say it's done half with the rendering, like the rest of it would be normal view and the top would be rendered normally. Best case. A worst case, it would do multi-threading stuff. What I really have no control over what it's going to do, right? Um, but yeah, a sky sphere would be really cool, and it would add a lot of visual flair. And I think it would actually be very simple to implement because we already have textures, right? So all we would really need to do for a sky sphere is I think have a texture, and then we treat it as a sphere, and we simply sample based off that. You know, I think that might be good. I do think I do think a sky sphere would add a lot. I think that would be pretty cool. So um, yeah, so I think we can just use OpenGL skyboxes for it, or cube maps. Although I would rather have a skybox than a sky cube. Because a cube is it kinda looks meh in my opinion, usually. Uh, and oh yeah, a second problem with a cube would be that we oh, but both actually would have problems. I'm realizing, right? Because a sphere will have the problem that the poles get how would you call it? The poles get crimped together, right? So the texture gets warped near the top and bottom. Although the center would be pretty okay. A skybox just has some problems at edges, so I think a skybox might be better. So what we really need to do, I think, for skybox is yeah. Although for ray tracing we might be able to cheese it. Hmm. There are a bunch of interesting information about it, and let me see if I can find something interesting about this because this might be a lot easier than I think it would be. Skybox. Mm-hmm. Yeah. Hmm. Yeah. How would we actually approach this? Oh, I found a potentially good source on this. Okay. Yeah, so if we need to spherically map it, sure. Yeah. Mm-hmm. Mm-hmm. This is a long article. Wait, let me put this on stream, right? It's a bit more interesting than just me talking, right? So this article about texture mapping, right? So the cube map, right? Was basically like we would have 1, 2, 3, 4, 5, 6 textures that we would sample from. So we need to know which site we hit, and that we can basically get the texture coordinates. Yeah. So this is the basic function from like the pseudocode to check the site, and then yeah, the printflow things. But I'm wondering if they have anything on skyboxes. It's like Google skyboxes, right? Skyboxes. Okay, cool. Oh, okay. These are cool skyboxes. Sure. Yeah. Okay. Sure. So these, right? I think these are probably in. Okay. Yeah, so we just made the sphere very big. Okay. Right. That seems so cheesy. I mean, we could. Yeah, we could really do something cheesy here. I mean, we have ABBs, right? So we can just we can really cheese this, I think. Yeah. I think it would be possible to cheese this. I think we could go with a sphere, although these are all oh, there it has so many pages. Okay. So let's go with a cube, right? And then we can use this algorithm to deter. Yeah, so we need cube mapping. Cool. So we basically need to find the these things, and we can use this pseudocode for it. And we could just use a bounding volume hierarchy. Sorry, BVH node for this. I think. All right, I think we might actually have an AABB. Anyway, yeah, cool. So we can use this, and then yeah, we just need the UV calculation. Okay, sure. I think we can work with this. Okay. So we need some kind of skybox. I think this would be this wouldn't be under graphics, would it? No. Window. Yeah, let's just add it here. Sure. Add class, and then we can name this. So I really dislike that it doesn't show this window by default on stream. So we can call this skybox, right? Then I need to set up the includes. Include. This can just be under core. Sure. And this can be under source. Core, and then core. Yeah, there we go. And then we say namespace RT, because everything is in a namespace. Right. I think what we only really need is we can say public, and we could do skybox, right? And the only thing we take is an std string, const std string reference, and this would be base tier, right? Because we're gonna need to load in 6 images, and passing all the names in manually would be a pain. So we just pass in the base tier and just assume the names. This would be include string. Okay. So this will load in the skybox, right? And of course it's going to complain. And it would be core skybox. And then we create the definition. Okay, cool. So the skybox has private. I think we have an. Did I make an ABB? No, I think I just made a BVH node here. Yeah, that has an intersect. Okay, so we're just reusing the BVH node, I guess. Sure. We can do struct BVH node, and then just do a BVH. No, we actually need to include BVH node here because we can't. I mean, we could make a smart pointer, but that kind of feels stupid. So I think we could better. It would be better to just include BVH node here. Oh, this would be under core BVH node, and then we would have a BVH node skybox and sorry, mdot box. Okay. Cool. Then we need a intersect. No, this would be a GLM vec3 intersect. And this always hits because it's going to encapsulate the entire scene. And this would take in a const rt ray reference, and this would be ray. Now we of course need to forward declare ray. And I think that's it. We don't care about anything else. And that intersect function can just be empty. Okay. Then we can have a private function that would be glm vec2, and we would need to include this, and this would be calculate uv, and this would be let's figure that out later. Right, so first the intersect, right? We need to calculate the face. So we'd have here an enum. Let's declare that in the header. So we'd have a private enum class e face, and this would be, what faces did we have? We have left. Oh, let's actually go by the So we have left, right, front, back, up, and down, right? Okay. So we can say that we want the intersect function. Okay. Right. Your cube mapping implementation will assume that it is mapping onto a cube with one corner at point -1, -1, -1, and the opposite point at 1, 1, 1. It's no coincidence that this is also the exact dimension of the cube's CPU Raytracer. Okay, sure. Yeah. But array doesn't necessarily go through the origin, so how are we going to do that? Yeah. When wait, what? Okay. So we have this weird function this pseudocode. This kind of looks like Python, maybe? I don't really know. Oh, this is a big nested loop. Okay. Maybe. Right. So, we can say absolute x. Okay, sure. We have float. I think we can just do glm vec3 absolute, and that's equal to glm absolute, and that would be... Oh, we need some sort of intersection point. Sure. glm vec3 hit, right? Yeah. What? Okay, weird. And then we just say hit with absolute. Okay. We don't know this hit value yet. We're gonna get with that later. First, we're gonna decide which side we're at. Okay. So, yeah, I think we can do floats glm max or float chord equals glm max, and it would be hit. Oh no, sorry. Yeah, this would be absolute. Is there? I think there's a... I think there's a way to get the max component. Pretty sure. Okay, there is a max for this. I mean, we can just do... Oh, okay. What I think we can do is we can include a different glm library, or a header file. Sorry. So this would be glm slash gtx slash extended minmax, right? And then there's the x, abs.y, and abs.z. No? You literally say, returns the minimum component-wise value of 3 inputs. Why are you doing this to me? Right. Okay. There must be some function for this. Yo, Sidbu. Welcome to the stream, man. I'm making a ray tracer, and right now I'm trying to implement a skybox. But yeah, I'm trying to find some glm documentation for something. But yeah, let me show you what the ray tracer is doing currently. Right, so we now have potatoes that are refractive, that basically light through, right? And we can also change them to... I'm actually not from the UK, I'm from the Netherlands. I am completely Dutch. What about you? Yeah, Netherlands is good. But right, yeah, so you can see that we have texture support as well in here. Oh, nice, nice. But it must be pretty early in Canada right now, right? So anywhere between like -6 my time and like -8 or something. So that would be like... yeah, okay, that's actually later than I thought. Is it early? No, yeah, that would be, I think, -6 hours compared to me. Because here it's a quarter to 11. Anyway, yeah, it's actually quite late. I kind of forgot that time. Anyway, but yeah, we can see the ray tracer is rendering potatoes. I can render other models as well, of course. And there's some options like viewing normals, viewing depth. Although I really don't like this feature yet. It's too hard to differentiate. So I'm changing it, but it's not that important. Oh, okay. What is? No, I actually never heard of it, but I've just googled it real quick, and it's next to Morocco and Liberia, right? So it's northern what is it? Northern Africa. I mean, to be fair, what wasn't? I mean, didn't they colonize like half the world? French. Okay, so I just looked it up, and it's actually depressing. Like, it's just an entire Wikipedia list that just doesn't end. It's like in Asia. Oh, like here's like 20 things we conquered. This is insane. Holy, sorry, I got distracted. Right, anyway, so I was getting some to Raytracer features. Um, so yeah, right, we can view the depth view. We can also see the bounding volume hierarchies that's actually creating, and it renders them out. And we can see how expensive pixels are to calculate, so we can identify hotspots, right? And this is about what we expect, right? So air is cheap to yeah. So I'm actually using two BVHs. So there is one low quality BVH for the entire scene. So it operates on model level, right? So it splits the models in a BVH. And this one is quite quick to build because it's not that accurate. But it gives you a quick idea which model to hit quite easily. And then there's a higher quality static one that is built and serialized on your computer for the models themselves. So I think that's a good mix between performance and time. Because the model BVH can actually take quite a long time to build. Like, say a few seconds to 10 seconds. What I mean, it's fine if you run it once and save them, but if you run them every frame or every time you start them up, it's kind of annoying. But yeah, oh yeah. What I was doing, I keep losing track of what I actually wanted to say. So currently we just have this green background, right? And it's kind of getting on my nerves, especially with refraction. Everything just becomes green. So I wanted to implement a skybox so we could have some more interesting reflections and just a bit more interesting shading in general. So I thought that was cool. So yeah, I was basically just working on implementing that. So yeah, what we basically need to do is yeah, it's a ray tracer. The only thing that's rasterized is the I mean the UI and the bounding volume hierarchy. Ah, interesting. Yeah, I've been wondering about it because if that would be better. This uses just bounding volume hierarchies, but there's only triangles here. Currently, I don't support anything else. Yeah. So that was actually one of my plans as well. Not for this stream, but I kind of yeah, Monte Carlo, because the I'm currently just doing with it still, and although it produces decently nice images, I don't know, it's just kind of meh. So I plan soon when I have a bit more features to switch it to a path tracer, or I might make it a swappable ray tracer. So I can swap out the ray tracer itself to a path tracer. What would be very doable as well. I think that might be even cooler. So I can switch the rendering or the renderer itself. Because, I mean, all the ray tracer class is, right, is just the ray tracing algorithm. So to get path tracing in, all I would really have to do is create a new ray tracer class. Yeah, that's the only issue. I would have to change some things, but I think it would be pretty doable. Or what you can do is you can treat your point light as an area light. So what you could do is merge them basically, and in widget style treat it as a point light, and in the path tracer treat it as an area light. That would be a possibility. But yeah, there are some limitations, but I think there isn't that much difference uh, in that sense, right? Because the most of the things are like BVH, right? It's just the scene, and it says, "Oh well, scene BVH intersect," right? Like the actual like ray tracing part is only like 230 lines, right? So just making a new ray tracer is quite simple. It's really the stuff around it that's hard to do. Yeah, okay, that's true. But I mean, with the widget style, right? You could simply have your point light have a radius, and in your widget just completely ignore that radius. But yeah, I've been thinking about that, but I have done a little bit of portrait. Okay, let me actually share a different project that I've worked on before. Um, that's also a ray tracer, right? This one. Yeah, there is a bunch of interesting things you have to take into account, and I've done a little bit of it, but not nearly enough. Right, let me switch to this real quick so I can actually show you the other ray tracer without having to change a billion things. Right. So this is the ray tracer I made last year, and I think it looks a bit better, like visually, but I think that's also a big part because the um, well, yeah, it's real time, okay, but I mean, I am throwing a ridiculous amount of CPU power at it. So I mean, it's real time, but eh. I mean, the other ray tracer was actually way faster than this one. Yeah, that's an expensive CPU. I um I needed it for school. It's my official uh statement there. No. Yeah, so there's actually no particular no, there is actually okay, so the reason I'm doing it on the CPU is because I thought it would be a fun challenge. Because you would definitely notice the need for optimization more, and I kind of just wanted to push the project to see how far I could do it, right? I know it would be better with like OpenCL or like anything on the video cards, but I thought just CPU ray tracing would be cool. But yeah, this it has a pretty similar feature sets. Um, it has texture support, but this one uses primitives, and uh, yeah, that as well. I might make a GPU version though at some point because I am interested in that. But yeah, it looks better, but I think it's mainly because the scenes are better set up and the primitives provide some really nice things. But I think technically the ray tracer has almost all the features. The new one has some issues with reflections. If they're it, it only does refractions at the moment. I need to fix that. And this one has normal mapping. Yeah, it is. So, you want to know something funny? This is actually, I was just looking into normal mapping. Wait, I don't know how that disappeared. But this is actually one of the easiest things I didn't expect it to be. Because when you have texture support, right, you already have normal support. Because all you do, right, you just get you just store a normal texture, and then you just multiply the normal with the value you get from the normal map. So it's actually really really easy to do. Yeah, I think I used like the the purple like normal maps, right? The newer versions. But yeah, the Earth uses it here as well. Yeah, I think so. But the thing is, the nice thing with these are, it's primitives, right? So I can just use simple math to actually calculate everything. But yeah, I was surprised at how easy it was. But yeah, the new ray tracer can pretty much do all of this, but it's a bit clunkier. It's Because this was a project for school, right? So this was 8 weeks of 40 hours. And the other ray tracer, I think, has like about 2 weeks of development in, right? Like effective time compared to this. So it's not as feature rich. Then we have some other scenes. And we have scenes like this. But yeah, you can see this is struggling very, very hard. But we can clearly see the difference here because this is running at 3 FPS and effective. I think this is like 5,000 models, right? And the other ray tracer is running 50 potatoes at like 15 FPS. And I think each potato is more triangles than it is. It is. But I think it's just a really shitty ray tracer implementation. BVH implementation, sorry. But yeah. So something funny about this BVH is actually ray traced as well, the visualization for this. It's the most horrendous code you've ever seen. But yeah, the ray tracer has some other cool features I added in last moment. Let me see what it was as well. So yeah, you have the screenshot mode, right? So this kind of turns it into a path tracer, a really shitty one. So it freezes basically everything, and it has let me open that, right? Okay, no, this was a single project. But yeah, this one turns it into a path tracer, right? Kinda. But yeah, it doesn't like the boxes too much. It gets some weird artifacts. But it has depth of field and stuff. But yeah, it's pretty cool. But it's just really, really slow. Yeah, thank you. Oh, and this is the funniest one. So we had to make reference scenes. So I decided to just make a cube with the reference scene on it. I was like, yeah, this is good enough. Nobody will ever notice. Yeah, I think the Duff is definitely helping there. But yeah, this is kind of what I achieved the first time. But yeah, it needed an update for my portfolio as well. So I'd be making a new one that much faster. But it needs a lot of work to be nicer because especially things like camera controls make it much nicer to view. Some lighting makes it much nicer. So, but I've been kind of lazy making good scenes for it. Oh yeah, so I want to show something. This is the most horrendous code I have ever created. I think it's in here. No. Yes. Okay. This is it. I found it. Right. So there is this function called getEdges, right? So what it does, it's kind of the regular ray box intersection, but it basically checks the intersection point and checks like all corners and sees if it's like at the edge of the box, and if then it colors it, and if not, it doesn't. So it's kind of like an intersection, but it checks like if it hits the edges, and it's the most horrendous code I've ever seen. So yeah, the visualization of the BVH is actually rare. Yeah, it is right. This is so horrible. I was like, yeah, it's a debug tool. So when you run this, right, you are ray tracing that BVH extra, and if you add nesting, so if you, I think move the, oh, this only has one. So if you move this along, right, it basically bogs down because it has to like ray trace more and more nodes. Yeah, but the issue, right? I This is using SFML, I think, and I didn't like know anything about at that point about rasterization and projection and stuff. So I was like, well, I might as well ray trace it, and it worked fine, right? Because it's a debug tool anyway, so it was good enough. But the new ray tracer doesn't use this approach at all. Luckily, it's actually projected, and it's just using. It's not great code either, but it's much better. So it uses. Yeah, but I didn't know about it then. So there is this. Yeah. Oh, okay. Never mind. Yeah, it does actually. But the old Raytracer, we had to write our own math library for school. So this project uses GLM, but they don't want it. Oh no, I forgot that the other BVH is also horrendous. So for the drawing, right, I'm using just GL begin, GL lines, and GL end, and then I have to define all the lines. And I didn't want to do this with code like a for loop because I was like, yeah, I will just do it by hand. It's not that hard. And then I found out it was bad. But then, yeah, basically what we're just doing is just projecting that line and just drawing the vertices, right? Yeah, it's just an overlay. What is much more performant heavy. Much more performant than uh, the ray tracing method. But I think there is something slightly wrong, but I will figure that out later. It's not that important. It at least shows the BVH. I think the positioning might be slightly wrong. But that could be due to a number of reasons. It could simply be that the perspective camera is wrong, as in that the ray tracer and the projection use slightly different FOVs for some reason, and that creates a skewed image. But it's hard to verify that. But it's kind of a debug tool, so it shows me at least the bounds right, so it's good enough for now. Oh yeah, and it runs the BVH works now, so it's fine. Yeah, so this is more for fun than for school projects. So last year I did have to make it for like an actual school project. And this one is more for portfolio. So to kind of compare from what I've done to what I've come to, right? Yeah, so I'm a game dev student actually, so I'm going into game development. But, yeah. What about you, man? Uh, and then ABS.z. Okay. But what is SDF? Uh, so yeah, sorry, I don't know what SDF is, but okay, that's okay. That I don't even. Okay, that is some stuff that I don't know about. Oh, thank you. Ooh, that looks awesome. Oh, so it's basically that it keeps sharp, like however much zoomed in you are, or oh, that looks awesome. So, as a matter of fact, I've actually been doing text rendering today as well, and I would say it's an absolute success, and I completely know what I'm doing. But yeah, no, for our current project, we have to make a game engine, and one of the prototypes for that is that we need text rendering, right? Because the designers are complaining that we need to make UI, right? Like we need UI, but apparently we do. So we need text rendering. But yeah, I've been trying to. I can actually show you this. I think. Let me get this up real quick. Source. Yeah, I think it's there. Yeah. I'm just preparing the. Oh, nice, nice. Yeah, I would. I'm interested in it as well. UI, it's interesting, but it's a really hard challenge. I think. I mean, making the UI library itself might be very doable, but making it be able to produce game ready UI is very hard, I think. Oh, awesome. I look forward to seeing that. But right, engine, no. I'm just looking up the detect rendering thing. Right, okay. So what I managed to do now is right. So my current prototype managed to generate these images, right, from a what is it, a TTF file. It really is. I'm GUI that bad. I mean, I'm GUI really is a debug renderer anyway, so I think it's fine for the most part. But yeah, I think for game UI it's kind of shitty. But yeah, anyway, so in here I managed to load in a TrueType font and rendered the characters in an image. And of course, for text rendering, I wouldn't store them in an image. But for testing, I can't render anything yet, so it's easier to just save them to image. But it's apparently I'm doing something very stupid here, and I have no clue what I'm doing. So tomorrow, one of the teachers is going to look at me with this because, yeah. So why is everybody saying I need to use this? Maybe there's a point here. Right. Okay. Let me show you the horrendous code here. Right. Yeah. Yeah. This is fun to share. Yeah. So that was kind of my idea, right? I would create all the textures for the alphabet, and then the designers could be whoop whoop whoop. I want to type this, and then it renders it. So right. So what I do is I have the font info, right, and then I do SDB this thing dot init font. I can't pronounce the name, and then I'm getting stuff and I'm making an image out of it. I don't really get it, but one of my teachers apparently has a sample, or not sample. He in his game engine he actually did this, so I can take a look at this. Ooh, that looks awesome. But yeah, that's basically what I've been trying to do. So I'm just trying to create a map of characters, so I can just yeah, I get that. But yeah, so I've been trying to get text rendering going. But yeah, of course it doesn't render anything at the moment because yeah. But yeah, for this image I just put arbitrarily 5,000 as a size or something, and that renders it. But the output image isn't 500 by 500, and yeah, I really don't know what I'm doing. But yeah, it generates things. I know. um, but yeah, uh, I would appreciate that actually. Right, let's see if we can. I mean, if you don't mind, I wouldn't mind improving this. But really, yeah. So wait, yeah, wait. You have this learn. Yeah, right. So you have this, right? So you mean this, right? Like the glyph metrics. Right. Okay. Okay, that would actually be very helpful. I mean, I clearly found out my life goal now. I'm just asking Twitch chat to fix my homework for me. The ultimate solution. No, I'm joking. It's not really homework, but right there we go. Paste bin. Okay. Yeah, this is using Scenes Barrett's library as well, right? Right. Bool. Right, and that is just a vec2 of dimension, sure. So what's the difference between, because I'm using this, right, the STB true type. What's the difference between true type and recpack? Or are they both needed? Because oh, okay, so true type is basically just a wrapper for it. Okay, got it. Okay. But yeah, the kind of the issue, right, is that these names are I think incredibly horrendous. Like SLB get code points like H metrics, right? Like what? SLB get code point bitmap box and SLB make code map. Yeah, like if you aren't familiar with this, it's like what? And then but you have done the other one, right? SLB write PNG. I can understand that. I mean, this probably isn't that bad, right? But I was really tired, and I just couldn't find a good example on how to do it. And it's kind of like you're turning in the dark, and you don't really know what you need and what you. And it's kind of like playing around. But right, would you mind if I showed the code on? I mean, you already showed it in chat, so I guess it's fine. Um, okay, so I would need the library then. Um, okay, so just yeah, okay. So yeah, you load glyph, and the glyph in this case would be like the letter E, right? I'm guessing. It would be similar to I think this. What would be no? Yeah, this. So you get the metrics from the letter I or sorry A B C whatever. Okay. Then yeah, you get the bounce. What I think is um okay yeah, I'll wait for that then. But I think the biggest issue with this code is that it kind of it's just hard finding an example. And I think once it clicks, it really shouldn't be that bad. Okay, thank you. Right. Yeah. Right. So we have a vector. Yeah. Sure. So this would just be like your ASCII chart, right? I think. Am I seeing this correct? Yeah. So 33 till 126. Yeah. So you skip the what is it? The first 33. Uh, and like I think like the the characters you can't type, like the new line stuff like that. I think what is the first 33 characters? Line breaks, weird stuff. Um, yeah, oh yeah, control charts. So then, yeah, you just push them back, sure. Um, okay, sure. Glyph size, yeah. You just load the glyph, normalize. Yeah, and this is just the dimension. Yeah, and then the scope of the pixel. So this would. So the one thing I'm curious about is it like this kind of generates a texture in the end, right? But then the scale, if you were to scale up the texture later on, it wouldn't do it. So I'm guessing this is only done when you load it in, right? So you say I want to load it in a bigger scale. Is that correct? Or can it scale it later on as well? Or do you have to then generate new textures? Or do you scale them up in shaders? Okay. But yeah, you just get the bounding box. Yeah. No, I actually have that exact same code here. So I think this is the bitmap box, right? So just pass the info, I, scale. For now, for testing, I just yeah, okay, sure, that makes sense. And scale for now is just one. Then yeah, this is bounding box. Okay, sure. Then going back to your code, return true, return false. I'm actually curious. Why does it do? Oh, this is if it fails to load. Yeah, sure. Required dimension. So is this a custom moth library, or is this GLM? Just curious. Okay, nice. Right, sure. So we go over. Get, and then I'm guessing this is glyph ID, right? I'm guessing what this is standing for. So glyph ID and glyph IDs. Oh. Wait, software floats. Okay, that's awesome. That's really cool. Wait, well, I'm curious about something. Why would you ever need software floats? Wait, but if you have software floats, would that mean that you could create very accurate floating point values that would be more precise than a double? Wait, mobile doesn't have like actual floats? Because I know they use software floats on like the Game Boy, but I didn't think it was I didn't think that was actually still like relevant today, unless you're like talking about like really like embedded hardware, right? Um, Wait, an ARM as well? Wait, because I've actually developed for ARM 64. Okay, wait, all ARM or just ARM 32? Huh, that's actually new to me. Okay, that's actually very interesting. Because we had to make a space game, and I think people were using actual like trying to get like realistic sizes going, like for actual Earth. Um, but if it's half flood, that would actually be a possible um explanation for why it would mess up, because half floats would have quite low precision. Huh, interesting. That's really cool. So this required dimension thing, right? This just adds some padding, or oh, okay. Oh, no, cool. That's cool. I never thought about that. But it's one of the things I'm noticing about my education, right? A bunch of things I never thought I ever needed. Once I started using them, they become incredibly useful. Uh, right. Okay. So fonts. Yeah. Shape font. Okay. Yeah. Oh wait. So this calls this function. Yeah. So this is the glyph bounds. Yeah. Then we add pixel padding times 2. Okay. Then area plus equals dimension of area. Okay, sure. Width, yeah, sure. So why is the next width actually squared? The log of the width. Yeah, this. I'm curious about that. This magical line. So the CO of the log of the width divided by the log of 2. Isn't a log of 2 a special value? All right. Okay, there's actually quite a lot of code here. Okay. Yeah. Okay, sure. Uh. Okay, really? Ah. Oh. Yeah, no, that makes sense. Oh, yeah, I'm guessing it's some weird moth thing. Wait, isn't there like yeah, it's really cool. I thought there was some really like I think there was like a really cheeky way to get the next power of 2. Um I thought there was a really cheeky way you can use this with binary to do this. Let me see that real quick because I'm pretty sure there is. Um, I think you can do something like this, right? No, I don't remember, but I think I saw this somewhere in a project. Like, oh, nice, good. I think you should be able to actually view on the stream what it is. I think, unless stream the plugin spazzed out. I think yeah, oh, yeah, you can click on the stream. There should be an icon on the sorry, the audio. Yeah. Oh, nice. Right. Okay. So sure, yeah, this just gets the neck bar of two. Sure. Yeah, and then we pack it. Okay. Yeah. Oh, this is the big function. Okay. Sure. So we get yeah. This is the rectangle count. Sure. Um, context. Okay. Okay. So I'm actually. So you have malloc, what is just memory allocate. Then you have calloc, what is. Right. So you have calloc. Well, yeah. Right. Because I. Oh, really? Huh. That's a thing? Okay. I never knew that was a thing. That's really cool. Wait, but why would you do that instead of making. Yeah, I probably should, but that's a lot of work. Um. Huh. Let me put that link or that term and put it in Google somewhere so I can save this. Okay. Sure. Anyway, that's cool to know. Okay, so we have rectangles. What is just the yeah, sure. Basic code. Yeah, then we have node, and I'm guessing a node here is basically a character, right? And then we go over the number of sure. So rectangle is yeah rectals I sure. Glyph. Oh, okay. Oh, okay, sure. Cool. So we don't have the fonts, glyph size. Wait, so what is this font? Oh, okay. Oh, okay, sure. Oh, that's just the class. Okay, cool. Then was packed, sure. Yeah, we just had it x0. Um, no, pixel padding. I'm guessing this pixel padding is like 2 pixels, right? Okay, never heard about that. So just add some space between the letters, right? Yeah. Oh yeah, and then it just sets that to. Ah, okay, cool. And then rectangle's ID is GID stored E. What is. Yeah, sure. Yeah, okay, printf. Okay. So then set up allow out of map. Okay. So we can just go out of what is this function? This seems very, very sketchy. Uh but but init target, right? Yeah, and the init target I'm guessing is just the yeah, it's context and context is oh, okay, that's this, okay. Sure. I'm gonna say is packed as false. Okay. And then we try to pack it. Okay. is packed. I think my teacher was actually talking about packing as well. So he asked me a question. Let me double check this. Yeah, so to be more precise, are you using STB pack font range? And I was like, what? So I think I do need to do something similar to this, but then with the true type code, right? Because it's using the different type. But I think it should be pretty identical. Right, sure. So yeah. So I'm guessing it just kind of has a wrapper for the packing for true type. Okay. Yeah. So if it's packed, then yeah, count glyph. Yeah, calculate the padding, sure. Okay. Yeah, so we actually define the glyphs. Okay. And I'm guessing the bake is the part where we actually, yeah, we create the image. Okay, yeah, I guess as much. So I'm actually curious about something. You're here making it an RGBA image, but I think the tutorials I've been finding it just uses a single component, so it's just black and white. But obviously it's very limiting because that means you can't have any color in your text. And then you just get the shapes, load glyph, okay. Oh, okay. Sure. Yeah, I mean there are some methods, but it's more limiting, let me put it like that. Yeah, and then you have this bitmap, right? Okay. Sure. Yeah, and you have this the image. No, right, but this is very helpful, right? This is actually very, very helpful. So, I had one more question. Is how I mean, probably have more questions, but the one question I had was, say I'm rendering, right? Because let's say I want to render the string "Hello World," because each letter. No, you would only have one image, right? With this, you have one image that's packed. If that's correct, right? So, how do I sample? Oh, wait. Each image, each glyph has. Wait, the glyphs have then UV coordinates, right? And then in the shader, you simply. Oh, this makes so much sense, right? Because I was wondering, right? Because it would be really really slow to, um, if I were to render just each character in time, it would mean I would need to switch, yeah, like a texture like 20 times for each string, what would be really, really slow on the GPU. But with this, you could just say, hey, I want to render text, bind this image, and then just throw a buffer at it with like, hey, these are the indexes or the glyphs I want to render, do your thing. Oh, that makes so much more sense than the approach I was doing. No, this is actually genius. This is actually exactly what I needed. Damn. Thank you so much, man. This is really, really cool. Like, the text rendering is now making a lot more sense. And I think especially with the help from my teacher tomorrow, I think I should definitely be able to do this. But yeah, I would love to see the rest of the code as well. Alright, there we go. Thank you. Right. Uh, okay. Right. So we would have the free type, blah blah blah, boring, load, right? Oh, okay. Yeah. So you're using the free type library, I think that Learn OpenGL has as well, but I wanted to use STB for it. Right. Yeah, sure. So then we load the image in. No, it's completely fine. It's helping me a lot. Okay. Then we do this. Oh, okay. Cool, cool. Load S key. Oh, oh, that sounds like a nightmare. Like, not to hate on the language, but from what I know, Arabic is horrible for like typing. I mean, as in like from a software perspective, right? Because with English, it's well, I mean, you can either have a character or you don't, right? So if you want to get rid of a character, you just delete the last one. It's simple. But from what I know with Arabic, if you add a letter, it can change all the letters as well. But like, this is just from what I yeah. I think yeah, the text is invisible at all at the moment, right? With this, yeah. Right. Whatever. Um, is there a dark mode for this actually? Probably. Maybe. Yeah, that makes sense. Um, so horrendous. Like, who makes an app and then like paste but not have like a dark mode, right? Like, but yeah, no. Load sequence. Okay. I'm guessing this basically makes the buffer. I'm guessing for the from the ASCII string. Okay, right. Yeah. Okay, this is really really cool. Right. Right. Okay. This is okay. Yeah, this is just a quad, right? Yeah, because you need the quads for the text is rendered on like a quad, if I remember correctly. Like the text would just be a vector of quads or whatever, or an array of quads. Sorry. Okay, no, that makes perfect sense actually. Okay, yeah, no, this actually makes a lot of sense. Okay. No, thank you so much, man. That actually is a massive, massive help. Um, yeah. That actually makes a lot of sense. Damn. No, just thank you for the follow, man. But no, that makes sense. I can definitely get this working tomorrow, I think, on school. Well, I mean, on school isn't technically correct because, I mean, it's locked down and no schools, but yeah. So yeah, so one of the things that we're okay, so I can't show this. What we I might be able to show it, but anyway. So lot no, I think I can show it. I just have to be a bit careful on with stream. Okay, right. Let me. Okay. Yeah, so we're making custom game engines for school. The issue is that we're making a custom game engine and we have designers and visual artists. So we need, an engine that is usable by people that aren't programmers. And we need UI, of course, because designers want UI. So we had a game engine here. It's not on the screen yet. Give me a second. Because I need to make sure I'm not showing code I can't show. Because there's actually code in here that I'm not allowed to show. So I just need to close all tabs. Right. Okay, I think this should be good. And then just minimize this. Okay. And then we can go back to here. Okay. Right. So when we rendered this, yeah, right. So it's a tower defense game, and it's very basic, right? But it allows for things like placing towers, and enemies should be spawning soon. And there are like little animations, sound as well. like the really annoying arcade sounds. And yeah, the levels have some height to them. So the levels are actually made in an external tool called Ukmo, and then they're parsed into the engine, and it's generating a level for it. So this was, I think, like I so I started like programming when I was quite young. So I think like 10, 12, I tried making Minecraft mods, but I only really started like actively programming about, I would say, 2.5 years ago. So not really that long. But yeah. But yeah, this uses a bunch of cool things. But yeah, I think this was a six. Yeah, this was a 6-month project that we had 8 weeks for. Yeah. But yeah, it's very basic, but it's completely made from scratch. It has a custom, like everything is custom. I mean, there. Okay, so we are using libraries, but it's from scratch for the most part. So the rendering API is using DirectX 12. That's like written from scratch. Um, no, you mean the Steam thing? No, it's just somebody of Steam. I should actually disable Steam for streaming. That sounds like a very good idea. So I don't actually show. Oh yeah, yeah, it's a team project. Yeah, yeah. Let me put this back up. Right. It is a team project. So this was all made by the team. So I was the engine programmer on this, so I basically did most of the like engine related stuff. But I have to be careful with the engine stuff. So one of the requirements was that it had to run on consoles, or at least we had to try getting it running on consoles. But yeah, as you can imagine, console code is under NDA and stuff. So I don't want to go into code about this engine for the potential of showing code that I'm not allowed to show, because that could be very, very bad. I mean, showing the game is fine, right? Because there's nothing NDA about the game, but there is potentially about the code. But yeah, this is the game I made with that. And it's using an entity component system for the rendering. Oh, wait, no, I can actually show some more cool things in here. So, I made some simple tools for this. So, yeah, whatever. So I have a console that shows error messages with docking as well. And it has a simple scene graph tool that shows you like all the objects in the level. And this is all made using MGUI. And the entity component system actually makes it really, really easy to do, because you can just say, just get me all the transforms and just loop over them, right? So everything is parented in this. There's one transform at the top of the world, and all the other transforms are parented it, or are parented to other transforms. So you just start at the root and you just go down all of them, right? And then you have your scene hierarchy. And you have the ability to move things in the scene. So you can move the world around if you wanted. That's pretty funny. I think I can rotate the world as well. But yeah, that obviously gonna do. Yeah. Also, the rotation is broken. But yeah. What's something interesting there? I mean, it's quaternions. Quaternions are broken anyway. I think so. No, just I think it's pretty much as it should be, right? It's not that broken. Um, C plus normally. Yes, and no, just I mean, C plus plus is a really, like, I think it's a really shitty language for starters. It's yeah, it's really hard to get running or get starting. Like, doing anything in C plus plus is quite hard. So my biggest advice would just be make projects and you will improve by leaps and bounds. Yeah, C is better, but yeah, I would say C is much simpler. At least, or I mean, not simpler to use, but yeah, for learning for sure. C++ is it's a mess. It gets even worse when you go into templates. Uh, templates are templates are great, but they're also horrible. You can make some really, really dangerous code with templates. So I made a like an event dispatcher. It's fully templated and does like function delegates, but it allows you to write code that is compile time fine, but then it caches at runtime. In my country, we need in exam we need use. Huh. Yeah. Yeah, Ray is also really nice. Some people love it, other people hate it. I'm mixed. It has advantages and disadvantages. Because what I like about Ray is that it's very simple, but it also like sometimes you don't want to initialize on allocation, right? But yeah, Notice, where do you live, if I don't mind asking you? Because I'm just curious where you have to learn it. Yeah, exactly. I think Ray is really useful like 95% of the times, but like the 5% that it isn't, it's a pain. Because then you deal with the fact that you have Rye, and then you need an initialize method to get around Rye. No, no, I know where Lithuania is. Kinda. I mean, I live in Europe myself as well. Yeah, there's a bunch of like weird stuff with Rye. Yeah, it's problematic, but it's really really nice as well because no, no, please don't, never, ever use namespace as STD. That's my personal opinion. I really really dislike it. I think the only acceptable case of it is for STD chrono, but then you use like using STD chrono or whatever, like you narrow down the namespace, because with STD chrono you get like wait, let me show this. So STD chrono is for timing, and you get like no, this isn't that bad. Yeah, okay, so this is like you get like these types, right? Like it, the times get kind of insane. So this would be STD chrono, high resolution clock to time point, right? So it's like this is the I think this is the only like acceptable choice I saw I see in it. I don't like using namespaces. Also, consider the following, right? So let's say I make a oh no shit, I don't want to write in here. I want to write in the Raytracer project. Um, so imagine I make my own vector, right? So I make my own vector that is similar, but it has the same interface, but it uses different implementation. Because maybe I want to use a fancy memory allocator, right? Um, but now, right, it doesn't know which vector I'm talking about. So if I do using STD namespaces, it's like, wait, what? You don't know how to use STD vector? What do they teach you? STD vectors are the best thing ever. So no, just I'm actually curious. What do you no, sorry. What's the reason that they say you should be using STD or using namespace STD? I can't count English. I mean, they if they're promoting using STD, I'm beginning to doubt that. But no, sorry, uh, shitty shitty joke. But if you guys are interested, I can actually show the game that I made with school as well. Okay, sure. Because we actually made one game that is actually shipped on itch.io, if you guys are interested. That was made with, I think, quite a big team. I think 10, 12 people. It was made with Unreal Engine. I can boot it up. Let me boot up the project real quick. Library. Yeah, there we go. Wait, what? 12 bytes? Sorry, yeah, sorry. I kind of skipped over the thing you posted. Compressed vertex. Oh, that's insane. Wait, 12 bytes. Wait, but that means that you can pack 6. Wait, that means you can pack 6 vertices in a cache line, right? Wouldn't that be very, very fast? Potentially? Yeah, because it's 36, that would be 64. That's glorious. That's really, really sick. I like that. That's cool. That's awesome, man. Right. Yeah. I mean, I'm not that concerned about saving memory, right? Because nowadays, like, you got so much system memory that, like, if the float is twice the size, who really cares? But for, like, speed ups, it could be interesting. Yeah, I think my vertex might actually be something like that, right? Because you're showing the UVs as floats, and then yeah, it's gonna be big, but it's really cool, and I definitely see the use case for this, like for sure. Yeah, it's definitely really really cool, right? But wait, let me put it like this, right? I think for like the projects of our skill, right, it would be like completely overkill, right? You wouldn't really notice the difference. Yeah, okay, that's a very valid point. Yeah, you're completely right. Anyway, I got the game ready. No, definitely not, right? Because it's kind of inaccurate to get the UVs anyway. Right. So yeah, this was the game that we had, right? And you could like customize your character. It was kind of a shitty multiplayer game. And the idea is that you whack people of a pig with a pool noodle. So you had 4 maps, and let's I forgot that the UI breaks in picture in editor. So it's like cool load screens and stuff. And there's like cool like Mario Karts and cinematics. I actually don't know about this music. Um, I don't know how safe we are there. I I think we might actually get in trouble for that. Wait, I think that might actually be problematic. Yeah, let me actually mute desktop audio real quick, because that might actually be copyrighted music. I don't know what the artist did or the designer did for that. All right, let me rehost this. But yeah, no, I definitely agree there. I think optimization is like a really cool challenge. I think I did kind of the same with here. So my BVH nodes are exactly 32 bytes. Right, yeah, so this was kind of the basic idea, right? So you would walk around, and you have the scene, right? And you could do some cool things. Yeah, it looks kind of cool and pretty, but the gameplay is really horrible with this. Yeah, I just want to show that. But yeah, what I can show here as well, like with the oh, cool, epic. Why do we crash? What really? 7 megabytes, Jesus. That's pretty big. Because if you would have like a few, whew, that actually adds up. That's pretty big. I mean, like if you have eight gigabytes of video card memory, it's probably fine. But then, like you said, if you want to run out integrated graphics, you're usually dealing with like very limited like memory that you're allowed to use, or integrated devices as well, right? You could only have like 256 megs or something like that. So if you only have, if it's already using 3 megabytes, you're already using about 1% of your available memory for like one font. Whew. Yeah, that definitely adds up for sure. Yeah, but I want to show the BVH node. Right. Of course, skip the BVH node. Yeah, right. So we have the BVH node, right? And it's exactly 32. Yeah. So we have 6 floats of all 4 bytes, so that's 24 bytes. We have a union here of 2 UNs32s, just to make coding a bit easier. And then we have another 4 bytes for the count. Wait, that's not 32. Wait, 200. Oh, sorry. You were talking about that calculation. Whew. That is actually some serious hit. Like, that's actually very, very big. Oh. Guessing it's more like 3 megs or so? Or. Yeah, so that is. Uh, right, so that's 200. Yeah, 270 megabytes. Whew, yeah, that's. You are right. That's actually that many megabytes. That's like 265 megabytes. That's huge. Damn, you're right there actually. Huh. Okay. But I mean, even if you use a single channel, that would be like still like a quarter of that size. Huh. But yeah, this one is nicely aligned, and what we do then in the VVH, we do a align malloc. I now definitely get that. That's gonna make a huge difference then. Yeah, so here we're doing an aligned malloc for the nodes. So we align them at 132. Yeah, I was gonna say you're probably gonna have like a quarter or like half a gig to use. Yeah, I think the biggest dependent like it depends on what you're making it for, right? If you're making a game engine that's supposed to run everything, that this stuff becomes important. Yeah, I mean, wait, how much does the GT7? I mean, even the GT710, like I love like that's a kind of like office thing, right? It has like 2 gigs. Wait, the GT710. Wait, the GT710 it uses DDR, not even GDDR. Huh? Yeah. Oh, 950. Okay, I have a 1070 myself, but I think has 8 gigs. But yeah. Yeah, 2 gigs would be filled up quite quickly. Damn. Yeah, no, I get that why you're packing them. That makes a lot of sense. Yeah, no, I get that. I think that's a kind of an issue with the so in the in the past, right, when we had very limited yeah. I think one of the issues is that with the hardware we currently have, like the new hardware, right, we have so much computational power that like for a lot of games it doesn't matter, right? Because you have so much hardware available, like so much RAM, so much video card memory, so much like actual processing power, and even if you program things horribly inefficient, it just has enough processing power to just be like, that's fine. But it's only I think with bigger games that like if you run it on modern hardware, it struggles. But I think it's definitely very good to gain experience with this. But yeah, I think yeah, no, I think this is really cool. Yeah, older hardware, and I think I kind of like that about the like old school hardware, right? With like the Game Boys and like the old consoles where they did like really cool tricks to like encode like things in images, and like they did these really cool tricks to like pack as much data into as small an image as possible. Or I think like recently a guy made a game on a QR code, right? That you could actually scan and you could play because it would be code. Um, and I think like games like that sometimes just use the screen as like storage because they need some place to store things, so they just use pixels as storage. It's like really interesting because you could draw pixels and you read them out, but you couldn't make the memory somewhere. Yeah, yeah, but yeah. I think like there are definitely like a lot of room for this where you could improve things, but it's also about skill as well, right? Scalability. So, uh, yeah, yeah, ECS is cool. It's the bigger issue though is that uh, we have to basically have everybody in the team be able to use it because I think the OOP self programming is much simpler to conceptually get, and ECS is a bit harder to grasp for a lot of people. And of course, like I made the engine, so I know how to use it. But the gameplay programmers also need to be able to use the engine to make gameplay and write. So they can't effectively use the ECS. You run into issues. Yeah, I think the more you use programming and the more you go into low level stuff, the more uh yeah, it's a tool that as I think as you program more, you learn the issues from it. And yeah, I used to really like OOP, but I'm beginning to dislike it more and more because of the drawbacks it has. Yeah, and ECS, for example, is very flexible, but it's a very different way from programming. Sort of, yeah, yeah, definitely. And the and ECS is potentially just much faster because of numerous reasons. One of them just being a data alignment. Yeah, that as well. And I mean, the performance for things like virtual functions are quite big as well. Like virtual function are quite slow. Oh, okay, right. Um, um, yeah, base, right? And this would be and this would be const. You know what is kind of funny as well? So we have a lot of new students in year one, right? And they always usually start out with not understanding. Let me take a look at it. Um, okay, let me take a look at it. Uh, would you be okay if I put this on stream notice? I don't want to show code necessarily if you don't want to. Okay, cool. Right. So we have SStream, YoStream, IOManip, CMOF. What is Conio? Uh, okay. Interesting. Never heard of that. Okay. So we have the int main. Oh, okay. Okay, this is yeah, I don't like this. No, not to hate on your code, but I don't personally don't like code written in different languages, right? Mainly because it's kind of this weird mix, right? Because what you get if you write yeah, function program can be very powerful. Oh, yeah, but sorry, what I want to say, what I don't like about mixing programming languages with your like native language, like I would have the same with Dutch. Like the programming language is in English, and then you mix that with your own language, so you get kind of a weird mix in languages. Oh, sorry, wait, I'm not actually sharing the code. Oops, my bad. So you get this weird mix, right, where you have like a dual while, right? You fin dot close, but then the names are in Lithuanian, I'm guessing. Um, I mean, I get why you do it, why people do that, but it's something I personally don't like. But yeah, anyway, sorry. Um, and it makes it really hard for people to review code as well, right? Because now I can't really review this code because I don't know what it does right. Um, yeah, I think so. I mean, that would make sense with the Conio, maybe, because it's input output. Yeah. I mean, I completely get why you do it. I'm just saying, um, you're F out. Okay, interesting. Oh, before. Huh, okay. Um, I have used Shader Toy before, I think, but I've never gone too deep into it. But I do know about it. But no, honestly, when I look at this code, right, I can't understand what it's doing. I don't really see anything like very horrendous that I think like, oh no, this is completely horrible, except this line. I think this is pretty okay. Wait, there's actually something really cool, right? This kind of reminds me when you mentioned Shader Toy. So there is the um this was this video that a guy made a character from Moth. Um, can't find it that easily. But really, do you have a link to it? I'm just kind of curious. Okay, cool. But anyway, there was one guy that made like a really cool 3D scene, and like everything was buff. It was really, really cool. Right, let me put this up. One of the things that I did code, yeah. So you have this side. It's not really exercises, but it's kind of programming challenges. And I think these are all mostly user made, and there are some really cool ones in there. It's not liking Shader Toy. Why is it? Why is Shader Toy? But yeah, it has interesting programming challenges. Wait, wasn't it Redstone? Yeah, I think my computer is just being this is cool. But yeah, people have done some. Wait, is this like is STB like the Saint Barrett? Is this like the actual guy that made the library? I'm kind of curious. Damn. Yeah, people did some really awesome stuff. Look at this. Really cool. Come on, Shader Toy. Oh wait, this is the Redstone thing. Yeah. Alright, let me relaunch it because I don't think it's liking it. Yeah, no, I think it's my computer just not happy with Shader Toy. The common, okay. It actually has input and stuff. Oh, it's a DirectX issue. Okay. Wait. Oh, but this is that's awesome. Um. Oh. Do I need to reload this? Oh, I need to. I think I just need to compile it, right? Okay. Oh, there we go. Okay. So, how does this work? Can I figure this out? How do I place things? Okay, I can zoom in and out. Okay. I mean, a bit hard. I don't know what I'm doing. Oh no. Oh no, I think I broke it. Well, I guess we're going off into the void. I'm not pressing. Okay, I fixed it. Right, so we have keys that do things. Oh, Q and E. Okay, yeah, that zooms in and out. F. Oh, okay, that places the current. Oh, okay. Okay, yeah. And then, can we select these? No, we need to use keys, I'm guessing? How do I... Oh, arrow keys, okay. Oh, that makes sense, right? So we have... I'm guessing this is a... Oh, yeah, this is a block. Okay, sure. Right. Okay, then we have redstone, wire, right? And then this would be not powered, right? Because there's no repeater. But this would... Right. If I replace this with a redstone torch, no. Right, so I'm guessing it doesn't do like these kind of things. Because I think in Minecraft you could place the torch on the side and it would work. It does everything, okay. Oh, okay. Right. Okay. So this would be the torch basically on the side. Yeah, okay. Huh? Oh, redstone torch, right. Oh, yeah, I knew that. I knew that. Uh So would this be the side of the block then? No. Nah, it's fine. Anyway, right. So we can make gates, I'm guessing, and stuff. Oh, I had okay. Anyway, so we have 2 redstone torches. How do I make gates in Minecraft again? I did this once before. Minecraft. Uh, or gates. Okay. No, I don't want to use repeaters. I want. Okay, yeah, I got this. Okay, I found an example, right? So if we input, then we have a piece of dust here. Right. And then I think we have a block here. Right. And then I need to put redstone on top of it. Can I put redstone over the block? Yeah, so how do I put redstone here on top of it? Because I'm just trying to press F. Wait, what? Interesting. Yeah, try pressing F on Oh, you have layers. Oh, okay, that explains it. Right. And then we move a layer down. Oh, okay. Right. So then we need a redstone torch on the lowest layer. And that would be orientated like this, right? So that would be connected. Yeah. And it takes a redstone line here. And not the most grateful design. Yeah, they should be. Yeah, they should be XOR, right? So, now the signal's off. Now the signal's on. Oh yeah, it's okay. It's on. Yeah, because it's an OR gate. But if I press M, I can. Oh, I can toggle the. Oh, okay. Okay, that's cool. So if I do this, it's still powered, right? But if I do this, it's huh? Oh, okay. Wait. So this is. Oh no. Okay, I did it wrong. I set it up wrong. Okay. Yeah. Right. Let me redo the gate here. Okay. No. I'm getting the hang of this. This makes sense. So we have 2 blocks. Then we have a torch. That's set up like this. Then there's another torch here for input. I think we need to move 1 layer up and put that there. Oh, we have layers there. So the only thing I'm curious about is why this doesn't turn it off. Because I think it's supposed to, yeah, turn off the torch off when it's as an input, right? Although, oh, wait, you know what I can just do? I could just there, and then torch. There we go. Okay. Then redstone dust there. Redstone dust there. Oh, oops, these are torches. Did I just find a bug in your thing, or? And then there is a block here. Redstone dust, torch. Yeah, let's put it to lowest on set. And this. Tick. Right, so we have the output, right? And then if we remove these, yeah, there we go. Cool, there we go. So now we can see that we have an OR gate. So if you have either of these, we have an input. No, no, this is just OR, right? Because we have two, then it's on, and if we take, yeah. So if we have either one, there's output. If there's none, huh? It might be XOR. Yeah, I was gonna. Yeah, I might have made something different. I think I might have actually made a XOR. Oh yeah, no, this is definitely XOR, I think. Yeah, but this is on currently if there are no inputs. If there is one, it's on. And if it... Huh? What gate did I make? Right, so this would be an AND gate. Okay. Yeah, okay. I was just following some some Google image. I don't know what it was. Right, so this would be an AND gate, right? Because we need two torches to turn the thing off. Okay. Sure. And I think we can make it an XOR quite easily. Yeah, because so this would be an AND gate, right? To make an XOR gate, we would have yeah, this would be XOR, right? So we have a thing here, then we have redstone, block, redstone torch, um, block, redstone torch, redstone torch. Kind of hard to read from this image, but I think it's like this. Then there's redstone dust here and here. Then, yeah, no, it would. I can definitely imagine. Right there, redstone dust there. Block, layer up, redstone, torch, output. Okay, so now if we remove this, we have an input, yeah? If we do none, we have nothing, right? But now we have input, no input, XOR. Okay, so that works. Right. Right, so what you can do as well, right? So you can make I'm getting the hang of this. I don't know what I can use this for though, but that's fine. So you can make an XNOR gate, which is just an XOR gate, but then you have a NOR. Okay, which is an inverting, yeah. Huh. That's really cool. But yeah, this is actually really cool. But yeah, you could plan entire redstone circuits out of then, yeah, because it's the only thing that I think would be nice is to have that's sick, man. Holy shit. The only thing I'm missing here is like a light, right? So you would have like yeah. Yeah, like a light that would be either like it would be similar to a block, right? But it would be like dark when not initialized, or sorry, no power, and like yellow when it has power. I think that would be really cool. And levers would be nice. I don't know if you could. Can you turn these torches off? I don't think so, right? Yeah, I mean, I think there are games based off these gates. But yeah, I mean, technically, you have everything you need to make everything. Like, I mean, you could make a fully functional computer out of this, right? I wouldn't recommend doing it because that sounds like an actual nightmare. But yeah, I don't see what you couldn't do with this. Oh yeah, yeah. I think it's this one, right? Yeah, there are. Yeah, I see you made a pull concept. Ah, memory. Huh. 2 bits. Yeah. So I mean, yeah. So you can store infinite memory there. Yeah. But could you simulate more memory than you actually have? That's the big brain. Infinite memory, boys. No, I mean that wouldn't work, but it would be really, really cool. Uh, yeah, pretty smart. But yeah, but no, this is cool. Yeah, definitely. Yeah, it's pretty big. Oh, yeah, and then you have the buffers, right? Yeah. But yeah, shader toy is really awesome, and people have done some. Yeah, no, I can imagine. And people did some really insane stuff on here, like people made like a this right, like out of data. Like, how do you do this? I mean, of course, it doesn't render. Oh, I was a bit too quick there. But like, how? How? Yeah, I have. Antichamber is really, really cool. It's a really interesting game. SDF. I've been debating making a game like it, but it's really hard. Ah, that's so loud. Oh, let me put the music back on as well. Okay, thank you. Oh, oh, check a full screen. Oh, it's not liking that. That's awesome. Yeah, no, that's sick. And like as well, right? Like these are. It's only like like a few hundred lines, right, to make it. Yeah, like I love that, like the moth modeling, right? You can do some really cool things with it. I think, like people made some warning. Oh, okay, right. I think they have like a showcase, right? Yeah, whatever. But like people made pop tracers in Shader Toy. If it wants to, yeah, they like people made pop tracers. Like how cool is that? And they were better than mine. Yeah. And like as well, like the entire thing is like 400 lines to get like this image. It's insane. Oh, let me check that out. It's my computer's really not liking Shader Toy. It's taking so long to load anything from it. Okay, it's finally loading. Ah, okay, that would explain it as well. Right, let me just refresh it once more and hope that fixes it. I mean, my stream got a bit derailed into cool stuff like Shader Toy, but that's fine. I can always do the UI thing some of the time. It's not that important. The skybox, sorry. Oh, damn. I'm guessing this is metallic roughness. Oh, yeah, this looks like metallic roughness to me. Yeah, for sure. So, yeah, that's cool. So is this a skybox or skysphere? Oh, it is a skysphere. Yeah, it's a sphere. I can see the pinching here. Because I've been debating if I wanted to go with a sphere or a box. I think I want to go with a sphere because it's a single image to get the background. What I think is much simpler. Okay, sky spheres. Um, so we'll do that then for my ray tracer. I think the only issue is I need to find some images for it because I don't think I could just use any image for it because I don't think it will wrap nicely. Yeah, you have some interesting stuff there. Yeah, you just have like the thing to calculate the mapping. I don't think you really actually need sphere intersections either. Or I mean you might do, but I will see about that. I think you can choose it quite hard. Because if you just know the ray direction, you can calculate like the intersection point at infinity. And, you know, like the intersection point or something. Oh, okay. It crashed. WebGL. Oh, I think it's just running two things at once. It doesn't like that. Yeah. Oh. Oh, yeah. Okay, yeah, these ones. But oh, okay. Oh, so you do actually use the this image. Okay. Yeah, sorry, that was it. Yeah, that was the trick I was talking about, right? Yeah. So you convert it to spherical chords from that. I know I've used a trick like that before for skyboxes. Um Wait, we posted what? Yeah, this is cool. Right now, but in that case, I don't think. Wait, but then skybox would actually. Oh, it's dead. Wait, but in that case, I think I could actually do a skybox very easily. Okay, refresh. Huh. Yeah, but no, I think Skysters would be better. Okay. Yeah, because with the you get. Oh no, WebGL. But oh, why is there no WebGL? I mean, I think a spherical one is fine for my purposes. But wouldn't that mean that if I have already have yeah, chroma stripping, but if I have texture support already, wouldn't then the skybox only be a few lines? I think so, right? Because I just need to convert to spherical chords. Then from spherical chords, I calculate the UV, and then I simply get the texture or the pixel for that. Yeah, who cares? Nah, I'm joking. I do, but that's for later, right? Okay. Yeah, I don't know, but Chrome is really tripping with this one. Okay. I guess we can't do that. I could try. this pains me, but I have to use the secret weapon. What is edge? This this plane. But yeah, I think I'm gonna change my ray tracer to a buff tracer. For sure, yeah. I will do that at some point. But yeah, no, this is cool. Right. This is cool. Oh, is this sphere? Is this a refractive sphere? Yeah. But yeah, I'm not sure about my current refraction, because I am debating if I should support primitives in my ray tracer, like perfect spheres, because they're really nice for like demo images. But I also like don't want to deal with having to support cubes, triangles, spheres, like, you know, everything. Ah, yeah. Because right now my entire ray tracer is built around um, triangles. What is, you know, kind of a problem. So I mean, it's possible to render spheres, but you know they're just made out of like 40K triangles. What, you know, isn't really great. Yeah, I mean, I could probably change it, but yeah, I probably should do that. Oh, now it's, oh no, it's not working, right? Um, huh. Well, it's open source, you say, but this is not a GitHub link or anything, is it? Huh, awesome. Oh, I see, right, okay. But is it broken then at the moment, or? Oh. Oh, okay. Yeah, nah, my materials right now are, oh, that's producing some cool images. The GitHub. Yeah, my ray tracer needs a lot of work. Oh yeah, this image 43 minutes to render, okay. Yeah, that's less interesting. I mean, it makes sense, right? It's yeah, 2,500 samples, high resolution, yeah, sure. But it producing some really nice renders. Anyway, okay. But then if I do this, I really don't need this anymore, do I? Right. Yeah, it looks great. My plan is to kind of go there with this ray tracer as well, I think. But then I mean, it's going to be a long project, right? Because I only work on this like during streams, so the progress isn't always that fast. Um, yeah, but I don't need the get face either. We can get rid of this, and this would be just uh file. Okay, right. But then and then we would need a texture. Uh, ooh, that would be nice. Yeah, for sure. Right, I think I can just say include texture here. Oh, wait. Isn't it graphics then? Yeah. Make unique. And this would be texture, RT texture. Ships. I think I misspelled the struct here. Okay. And this would be file. Right. So now we have a texture for the skybox. Okay. Then I think for the intersect, all we really need to do. Let me think about this. So we convert the ray direction to spherical chords, right? Yeah. I mean, what you're working on right now is still very cool, though. Right, so now I need to convert the sphere. Huh. Oh, I think it's actually very simple. Okay. Yeah, for sure. But I kind of been putting it on the back burner because you can have the most glorious material system out there, but if you Raytracer can't render it, it's kind of. No, I haven't. Sorry, I haven't read the code yet. I have it. I could download it actually. Whew, it's big. Yeah, I'm downloading it right now. Give me a minute. Yeah. My brain might not be able to comprehend it at the moment, though. It's getting late here, and my brain is getting tired. I like that the download is faster than the unpacking. Right, so while that's unpacking, I can. It's actually almost done already. Whatever. Okay, there we go. And then, yeah, it's using CMake, right? So I think I can just open it in Visual Studio. And I think that should work. So I'm actually a complete noob at CMake, but I've been slowly learning more and more about it. Yeah, I think I actually found the. I think it's this actually. If I'm correct. How I'm gonna go from there, or is those? Are those the UV coordinates already? The what is it? The theta and the other one. Phi, yeah, theta and phi. Is that directly? That might already be UV. Okay, so I just divide this by pi and this by 2 pi, and then I have the UV coordinates. Huh, okay. And then I think, okay, it would actually be very, very simple. Okay. I think we can actually do it tonight. So we can do that after I looked at the code, right? Let's see first if... Oh, yeah, CRay.exe. Okay. So let's see first if it runs. Oh. Oh, isn't this an option in CMake I can put on? Yeah, I do want to support HDR. There, you don't. That's fair. I don't actually know. Oh, so it might actually. Oh, oh yeah, it doesn't seem to be really doing much either way. See Ray. README. Internet Explorer, of course. There we go. Oh yeah. Oh, this is no. Let's open it in the OG. Okay, maybe let's not. Oh no, it's really not liking. Why did I open it in Internet Explorer? Can I use this in Chrome? No. It's great, right? I think I can just open it in. Yeah, there you go. I mean, Chrome does it a bit better, I think, but it doesn't load images. Um. Oh god, why does Internet Explorer do this better than Chrome? Right. Sure. Windows, yeah. Uh. Okay. Optional. Define UI. Okay. So I need to go to. I need to view the Solution Explorer. Right. So we need to go to. Um. Includes.h. Okay. Yeah. Because there was something about uncommenting something for to get the so to uncomment the define for the STL. I feel lied to. There's nothing commented. Does it even have the UI enabled? The readme is already lying to me. Uh, right. Yeah. Okay, that makes sense. Yeah. So I need to run it in the CMake GUI. I'm guessing. Okay. Let's just run this in the CMake GUI. Okay. So right click, CMake GUI. I've no clue what I'm doing. Yeah. Anyway, let's not try to render it. Let's just take a look at the code because I'm too tired to figure out how that works. Sorry. Right. See, right. So let's see. You were talking about the material system, right? Outputs. So I'm guessing this is render libraries. No. Yeah, I'm in source. Oh, material. C. Okay. I think I can just do. Okay, there we go. There is no header file for this, or oh, there is. Okay. Okay, pure C. Um. And these, I'm guessing these are the refractive indexes, right? I'm guessing, from what I can see. Yeah, IR, yeah. Right. So we have specular beer, yeah. These are just BSDF settings, sure. Okay. Ah, right, that makes sense. So you could just do like BRDF or EOR of type class and you would get this value. Sure. Yeah, hash table. Sure. Alright, and it has a material bucket, has a void value and a key, okay. Size, material type. Okay. Yeah. Emissive, default, warning, okay. Specular, BRDF, okay. This is a diffuse B, okay. Type def for this. Oh, okay. Right. Oh, hash. Oh, okay, it's all hash stuff, okay. Right. Getters, setters, sure. Okay. Inverse by. Right. Sample texture, yeah. So that's the texture UV, sure, and then you get UV. Oh, texture's filtered. Okay, so this is the filtered thing. Okay. Huh. That's pretty simple. And then it just does, okay. Cool. Get albedo. Yeah, sure, what just deep? Get albedo. Get roughness. Ah, some precombined globals. Yeah, absolute. Yeah, sure. Yeah, sample cosine hemisphere. Oh, yeah, so I think this is the yeah, this is actually what I've been needing, right? Yeah. So you would have R and phi, and then you would do this, and then you have the no, it's somewhere probably. I don't know what this is used for though, but this is really awesome. Oh, 10. Okay, cool. Oh, this is all just okay. Right, no, but this is nice. Yeah, my material system needs a lot of work. I'm seeing. It's yeah, it's not great. I might have to do a quite big rework of my ray tracer actually, from what I'm seeing. I think the hardest parts are well, I mean, I don't know if you want to see that, but um right, so the scene is the following, right? Oh, I closed the scene file. Damn it. Right, see you later. So it's just a vector of models, point lights, cameras, active camera, and then a scene BVH. And then a model is a shared pointer with model data, a material, a transform, and that's it. And the model data would be the actual triangles, BVH, bounds, and the loaded in material. And yeah, so it has. So this is a shared pointer, right? So there's only you only load in one model once, uh, and the only thing it would have is it would have its own material. But it also stores the loaded in material because you might want to change that because the OBJ might for some reason be black, the default material. Um, and the material is at the moment very simple. It's just base color and it has a texture. And then it does some math to get the UV coordinates from the triangle. And it's not really a great place in the material, but I didn't really know where else to put it at the time because I was only dealing with triangles, so I might as well make it part of the material. But yeah, I mean, textures are pretty simple to implement. The only issue is when you don't have UV coordinates. But yeah, it's very simple. But I think the ray tracer itself can like the hard parts can basically be this can stay the same. But I think it's more in the yeah. Oh, okay, I will do that. Yeah. Let me open that real quick. C-Ray scenes. Yeah, I'm just looking for the JSON. Give me a second. Right, scene Venus of JSON. Okay. And there we go. Okay. Yeah. Yeah, I found it. Right. So we'd have the renderer. Yeah, sure. This would just be random info. Yeah. Oh, so this renders from like the middle out. Okay, cool. It's full screen. Yeah, cool. Some just settings. Yeah, then you define the camera, transform. Sure. That's pretty smart. Scene. Okay. Output. Yeah. Hide ambient color. Okay. Oh, this is the old format, okay. Right, and you basically just define everything with position, radius. Yeah, no, this is actually really simple. Oh, and then for a mesh, you can say, okay, I want this OBJ, Lambertian shading, sure. Transform this, file name. Oh yeah, these are just all the meshes, okay. Yeah, and you just say the scale, position, rotation, yeah. This would be very nice to make, actually. I might do this as well in the future. Yeah, this would be better. Yeah, that's fair. Yeah, I was kind of considering making like a scene editor where you could create scenes. Um, but yeah, I don't know yet. I was thinking about it. But if I want to make an editor, I kind of need a. Yeah, I really don't know yet. I need to experiment with it more. But yeah, there is a lot of things I need to change. But no, I don't want to update. But yeah, no, that's makes sense as a format. Oh, check for another file. Okay. Uh, but there are a lot of files here. Okay, I found one. Yeah, no, I'm just switching. Yeah, I'm trying to not show too many of my computer what isn't necessary. Yeah, so yeah, so find the scene. So this is, I think this is BSDF scene something. Let me actually zoom in a bit. Right. Oh, this is new format. Oh, okay, yeah, I see. It's a bit different, but it's still pretty similar. Okay. Yeah, so you just define all the things, roughness, metal, and aspect. Yeah, sure. I don't know what these are, but yeah. Yeah, this makes a lot of sense. And you can just say, I want, yeah, this position, yeah, sure, radius, and then, yeah, with just any JSON library, this would, you can parse this and read this. That's really, that's, yeah, nice. That's the nice thing about JSON. It's quite readable, like, by humans. That's what I like about it. Yeah, no, this is cool. Yeah, no, definitely. Yeah, JSON is nice. I like it better than XML because it's very simple to set up and very readable. Yeah, for sure. But you know, man, I think I'm actually gonna call it a day here. It's like 1 a.m. here, and I'm getting really tired. But yeah, no, I want to thank you very much for the help, man. It's been amazing having you here. Yeah, and I have school tomorrow as well, so I do need sleep. Tomorrow's gonna be a long day. I have to start at 9, and then work, then school till 5, and then work from 5 till like 11. So I'm busy all day. Um, but yeah, no, but yeah, drop a follow if you want to join in next time. I do stream actually quite often lately. I'm basically streaming. Oh, you do? Ah, shit, that sucks. Yeah, like those errors always suck. But yeah, no, man. Thank you very much for joining the stream, and I hope to see you some other time. Might be a bit inconvenient with your time zone, but it would be good having you. Oh, that's like major bet levels of bad. Okay, damn. Yeah, I wish I could help you, but I think any any help here would be my brain would just not cooperate. I mean I can't even English anymore. It's that bad. Ah, yeah, don't use Rayman. Just don't, maybe no. Yeah, but I'm sure you can solve it. You've helped me a lot, so I'm pretty sure you can manage to solve this. Yeah. Yeah, no, that makes sense. That would probably actually help quite a lot. Yeah, handles already, yeah. That way the renderer doesn't have to deal with things, and you can have something like actually manage the things. Yeah. No, that makes actually a lot of sense. Oh, for sure. Yeah, no, man, thank you very much for joining the stream, and thank you so much for your help. It's been amazing. I've learned quite a lot today. It was really, really helpful. And I'm glad you enjoyed the stream and were around here. So, see you, man. It was good having you around.